Is it working? Yes. Okay. So at some point in time from this fixed point, the kite will reach this point, right? So this obviously, let's give it a name. So I'm not going to use distance right here. So again, I'm going to name it W. So this time at this point, W is this. But when the kite reaches this position, because he's moving this way, it is moving this way, then this will be W. And this will be, as you see, theta, which is smaller than this one. So obviously what we're asked to find, right, is d theta over dt. So the distance changes with time, though the length changes with time, and the angle changes with time. So now we're told find the rate of change of the angle with respect to time when, and this is W, when W equals 200 feet. At any particular instant on this horizontal, this piece is carved in stone to be 100. This piece, let's denote it by X because it's on the X-axis. You can denote it by Y, it doesn't really matter. And again, I have a right triangle. Now, what is this? Well, it's the rate of change of X, right? So at this position, X is this, but at this position, X is this. So here's another piece that changes with time. So W, X, and theta all are functions of time, except this that is fixed. This never changes. So what am I given here is dx over dt. Because he moves horizontally, so I know that this is the rate of change of x with respect to time. This I don't have. And I may not even involve it. And I don't even care. So we're asked to find how fast is this changing. And obviously it's decreasing. So the rate of change, this must be negative. Must be negative. I made myself a note. Okay, now, so what I would like to involve is this height and this, and not involve W because I don't have any knowledge about W. And of course, the angle theta. So this, and this. So when we look carefully at this triangle, what do you think we should involve what would you think of that involves this, which is the opposite, involves this, which is the adjacent, and involves this, which is the angle theta?
Trigonometric function like sine?
Sine is the opposite over the hypotenuse.
I'm sorry, tangent.
Tangent. So tangent theta is the opposite, which is 100, divided by the adjacent, which is x. Perfect. So now we can differentiate both sides. And I write myself another note again. X and theta are functions of time. Okay. So when I differentiate the left-hand side, as we know, tangent is secant squared theta times d theta over dt. The right-hand side is 100. When I differentiate 1 over x, we know this is negative 1 over x squared times the inner function prime, because x and theta are functions of time. So this is what I'm after. I will divide both sides by this. So d theta over dt equals negative. The top will be 100 over x squared dx over dt. And I'm dividing by secant squared theta. And now I can say when when this piece is 200. And you can say, but you don't even have 200 here. True. But the 200 will help me find x. And if I need to find, and I will, theta. So now, what does W being 200 mean? So I have here x, I have this 100, and I have this 200. So dx over dt is given to us as 8 feet per second. X squared has to be determined from the Pythagorean, using the Pythagorean theorem, 200 minus 100 squared, right? So x equals the square root of the hypotenuse squared minus the leg squared. So that would be this. Or since I really need x squared, I'm just going to say is 200 squared minus 100 squared, and that solves this. But now I also have to determine the secant, and this is theta. So cosine theta is x divided by 200, and I have x. Or I can say secant, which is the multiplicative inverse of the cosine, which is the hypotenuse divided by the leg, in this case squared. So I have to find x and then determine secant squared. So how much is 200 squared minus 100 squared? 200 squared minus 100 squared. Well, I know how to do that. I can simply factor, right? 200 minus 100 is 100, and 200 plus 100 is 300. So it's 300 times 100. So 30,000. That's what I get. I don't have to do that. I can just factor using the difference of squares. So we get 30,000. So this, it's already squared, is 30,000. And now the secant, so if this is 30,000, but this has to be the square root here because it's x. But x squared is correct. But this is 100, the square root of 3. So now I can determine secant, which is the hypotenuse over the adjacent. So this piece will be 200 over this. 200 over 100, the square root of 3. And let's see what we get. And also we have to talk about the measurement unit. So I'll simplify and then continue. Any questions about the numbers? Do I need to repeat any of this? Please don't be shy and say yes, and I'll show any of those pieces again. Anybody? Okay, so then I'll continue from here with the triangle. So on page 4. So here's the triangle, it continues here. So we have negative, and I'm going to write all of them again. 100 divided by 30,000 multiplied by 8, everything divided by 2 over the square root of 3. And it is squared, right? So 200 over this, that's correct, but it's squared. So 4 divided by 3. Now let's see what is left. I will simplify 2 zeros from here. And I have, if I simplify, let me write it so I don't mess it up. And times 3 over 4, because this is so much easier. So this is 100, and this is 2. So this is negative 0.02. Measurement unit. Anyone? Measurement unit.
I'm sorry, I didn't realize you were asking. It is feet per second.
Is it degrees per?
Yes, you are correct, but very good. Remember, in calculus, we only use radians. But you're right. The measurement unit for angle, which is radians per second. Yes. So in calculus, please remember all angles. I wrote angels. I didn't mean angels. I meant angles. All angles are in radians. Okay. Now, to be clear, if I have sine 30 degrees, can I not use this in calculus? Yes. Yes, I can. But if I'm asked to, so this is the same thing with sine pi over 6. There is no question there. But if I need to determine something, and we'll have this in this chapter, if dx, let's say, is 1 degree, this has to be changed into pi over 180. So this, you cannot use single degrees in calculations or degrees in calculations. Inside the trig function, it doesn't matter. If I put degrees or radians, it doesn't matter. The answer will still be 1/2. But if we're talking about, let's say, 30 degrees plus or minus 1 degree, this in our calculations have to be changed into radians. Okay, so please remember that. So yes, thank you. So it's radians per second. Awesome. Thank you for asking these questions. Anything else? Is there anything else that you would like to go back to? Anything else?
Actually, yeah.
Yes, I'm ready.
I have one last question. Could you do question 10 as well?
Yes, from the same section?
Yes.
Yes, let's take a look. Let me share. 10. Here it is. Good. So I have x squared plus y squared plus z squared equals 9. They are giving us dx over dt as 5, dy over dt as 4, and dz over dt as... Oh, that's what they want us to find. When the triple x, y, z is 2, 2, 1. Perfect. Okay. So there is no need to solve right now for z or z squared. No, just differentiate implicitly. Remember, though, x, y, and z are all functions of time. So none of these is just a simple variable. So then, and we have 2x dx over dt plus 2y dy over dt plus 2z dz over dt, and the answer is 0. I will divide both sides by 2, and I will solve for this. I will move this to the other side, and then divide by z. So I have x dx over dt plus 2y plus y dy over dt. Everything divided by, remember I moved it as negative, negative 2z equals dz over dt. That's what happens. I really don't like crossing it out like that. I always at least do it so it's clear. Okay, so x dx plus y dy, dx over dt over plus dy over dt. This becomes negative when I move it to the other side. So when I solve for the z over dt, I divide by negative z. Now I can put in the numbers, only now. Dx over dt, they say it's 5. dy over dt, they say it's 4. And the point given to us is in order 2, 2, 1. 2, 2, 1. So then dz over dt is divided by -1. So 2 times 5 is 10 plus 2 times 4 is 8. So this is 18 divided by -1, -18. They're not giving us any measurement units, so we don't have to worry about that. Is this better?
I'm trying to write down. Give us a second.
Oh, yes. Anyone has other questions for me? Anything? Very good questions. Thank you. Isaac? Yes.
I did have another question as well.
Yes, I'm ready.
Because I know you did a similar problem.
It doesn't matter.